Hello viewers, welcome to K Diagnostics. Dio here. Today we have a 2008 Chevrolet Express with a 6.0 liter. The complaint on this vehicle is the check engine light remains on while the engine is running. So we're gonna figure out why this check engine light is remaining on while the engine is running. So the first thing we're gonna do is we're gonna go inside the vehicle and confirm the customer's complaint. After confirming the customer's complaint, we're gonna connect the scan tool to the car to see what kind of trouble codes we have in memory. Once we retrieve the trouble codes, then we will know what directions we can go so we can fix whatever that's causing the check engine light to remain on. So now let's go inside the vehicle and confirm the customer's complaint. Alright, so we are inside the vehicle. So now I'm gonna start the engine so that we can confirm the customer's complaint. So the customer complains about this light over here. The check engine light remains on while the engine is running. So now I'm gonna start the engine. Let's see if this light is gonna remain on while the engine is running. As you can hear, the engine is running. Wow, this is weird. This is gonna make me sound like a liar. Now the check engine light is no longer remaining on. That's weird. The check engine light was on when the vehicle was outside, and now I brought it in the shop and turned on the camera. The check engine light is no longer remaining on, so that's weird. I believe we might have an intermittent problem. So let's connect the scan tool to the vehicle to see if we have any memory codes in the engine computer. So I'm gonna turn off the engine. I'm going to turn the key on. Let's see if there are some stored codes inside the engine computer. So I'll get the scan tool connected and then I'll bring you guys back up. Let's see if we will have some trouble codes in the engine computer. So let's get the scan tool connected. Alright, so I got the scan tool connected to the vehicle. So now let's scan it for some trouble codes. So this is a Chevy. This is a 2008. So let's auto ID it. So right there, the scan tool has identified the car. So that's good. Let's click OK. So let's do a whole system scan. So let's click on scan codes. This is going to scan all the modules on the vehicle. Alright, so right there, we have two trouble codes in the engine computer. The first trouble code is P0054, O2 sensor hero resistance, bank 1 sensor 2. So it looks like there's high resistance on the hero circuit of the second O2 sensor on bank 1, okay? And as you can see, it says test failed since DTC clear, history code. So these are history codes. That's why the check engine light is not on right now. So these are not current codes, they're history codes. So it looks like this O2 sensor here is failing intermittently. So when it fails, that's when the check engine light comes on. So I believe it's most likely working fine right now. And whenever it decides to fail, that's when it triggers the code and then the check engine light comes on. Because I was told that the check engine light comes on and off. So the second trouble code over here is P1174, fuel trim system balance bank 1. And the same thing, it's a history code, test failed since DTC clear. So this trouble code over here can cause the second trouble code to be set, okay? Because on some vehicles, the second O2 sensor, the one after the catalytic converter, is used to calculate the fuel trim numbers. I'm not sure if that's the case on this vehicle, but that's good to know. It's good to keep in the back of our minds, because if the computer is using the second O2 sensor to calculate the fuel trim numbers, if the second O2 sensor is not working right, it's gonna affect the fuel trim numbers, okay? So I'm going to address this O2 sensor trouble code first, and I'm sure once we fix this other trouble code will also be fixed. Because if the heater in the O2 sensor is not working properly, the O2 sensor will take longer to start working, because the O2 sensor starts to work well when it's hot. So vehicle manufacturers have put heaters in the O2 sensor to help it get to operating temperature. So if the heater is bad, if it's not working, it's gonna take longer for the O2 sensor to get hot so it can start operating properly, which can cause all kinds of things. So that's why if the heater circuit or the heater itself is not working, the computer senses the fault and then it sets the trouble code in memory. So it looks like we have two trouble codes in the ABS control unit. We have some U codes over here, some communication codes. Let's scroll down a little bit more. So right over here on the generic side, so mode 10, we still have two trouble codes, the same trouble codes. So let's address this trouble code first. And I'm sure once we fix this, this will also be fixed. And here it says manufacturer specific. Okay. We're gonna notify the customer about these two trouble codes, and if the customer gives us the go-ahead to fix these codes, then we will address these two codes later. But let's focus on the codes that are inside the engine computer first. So let's click on engine. It looks like this is gonna be pretty easy to do, guys. Usually when I see these codes, the issue ends up being the O2 sensor itself. So now what I wanna do, I wanna look at some data. So let's look at live data. So let's go to sensor data. I just want to look at pretty much all the data that are relevant to the O2 sensor. So let's customize this list. So let's look at some O2 sensor voltage data. And let's also get some amperage data for the O2 sensors. So 1, 2, 3, and then 4. Let's also throw some fuel trim numbers here. Let's get some engine temperature and engine speed. So that's all. So let's list these data. So right there. Now, the O2 sensor that has set the trouble code is this one over here. Bank 1 sensor 2. So we're gonna graph this and we're gonna compare it to the one on bank 2. So this one over here. So bank 1 sensor 2 and then bank 2 sensor 1. These two O2 sensors should mirror each other. So now I'm gonna start the engine. So right over here, guys, right off the bat, I can see a difference. These two O2 sensors should mirror each other, like I said. But as you can see, it looks like this O2 sensor is a little slow. It's not as fast as this one. This one is taking too long to switch. See, the one on bank 2 is showing 100, so it's going between 60 and then it's going all the way up. But this one is like stuck at 700. You see? So it's dropping. So these two O2 sensors should have mirrored each other. So now let's graph the ones before the catalytic converter. So right here, can you tell the difference? I mean, this one, these two kind of look like each other, but this one over here is like, you know, this O2 sensor has a problem. So let's look at the amperage draw of these O2 sensors. So over here we have the amperage draw of, the amperage draw of the heating element. So bank 1 sensor 2 is drawing 1.20. It's kind of fluctuating between 1.26 and 1.30. So bank 1 sensor 2 here is drawing 1.26 amps, and bank 2 sensor 2 is drawing 0. I'm sorry for the glare, guys, 0.92 and 96. So this one over here is definitely drawing too much current than this one. So these two should be drawing about the same amount of amperage. So this one is drawing too much current, which tells me that the heater okay, or the circuit maybe of this heater has a problem. It's drawing too much amperage. This should be close to this. So now let's look at the ones before the catalytic converter, because these are the ones after the catalytic converters. Let's see the ones before. And as you can see, bank 1 sensor 1 heater is drawing 0.76 amps, and bank 2 sensor 1 is drawing 0.76 also. You see how close to each other these ones are? They are basically the same. And these ones also should be the same thing. And as you can see, this one is drawing way more current than this one. So this O2 sensor, or the heater itself, you know, because the sensing element of the sensor could be good, but because the heating element of the sensor could be good, but the heater element, what helps the sensor to get hot faster, may be defective in this case. Okay, as you can see, this one is drawing too much current. So this is going to be a quick and easy one. At this point, what I want to do is I'm going to check the wiring. I'll make sure there's power and ground at the O2 sensor, and then if the wiring checks out okay, we will replace this O2 sensor. I mean, it's starting to work now because the engine is running. The longer the engine runs, the hotter this O2 sensor will get, and I'm sure once it gets really hot, it will start working fine. So the heater inside the O2 sensor is not doing its job. And I can see, compared to this one, this O2 sensor over here on bank 1, the second O2 sensor is definitely slow. So let me give it gas. Let's see what happens. So I'm gonna let off. Let's see how fast this is gonna react. I mean, it's hot now. It might be working fine. Yeah, so as you can see, this one dropped, but this one here didn't. Okay, this is kind of stuck. So look at frame 1. So look at over here. Look at frame 16 and 20. Look at frame 16 and 20 down over here. You see this? This one here is like stuck, flat. But this one, there's activity on the one on bank 2. So this O2 sensor is defective. So I'm gonna turn off the engine. Let's back out of here. At this point, we're gonna go under the vehicle and test the wiring. Alright guys, so we're here under the vehicle. The first bank is on my left and the second bank is on my right. So this is bank 2 and this over here is bank 1. So our sensor that's triggering the code is on bank 1. So up here is the first O2 sensor on bank 1. So we're gonna follow this exhaust pipe so we can get to the second O2 sensor on bank 1. So we're gonna follow this pipe. It comes down over here. It goes over, so over this cross member, so up there. And here's our catalytic converter, and over here is our O2 sensor. So this is the O2 sensor that's setting up the code, and the code is for the heater. So what we're gonna do is we're gonna test the wiring first before we replace the O2 sensor. So on the sensor side of the harness, or on the sensor side of the connector, these two white wires are the wires for the heater, and the other wires, these two black wires, one of them is going to be the signal wire, the other one is going to be the sensor ground. So we're going to test these two wires first. So these two wires that go to the sensor heater will be the pink one. This one over here is going to be the power supply, and the other one over here, it looks like a gray wire. So this gray, so this other one over here is going to be the controlled ground coming from the computer. So I'm going to back probe this first wire first so we can check for power at this pink wire. So let's back probe this wire and check for a power supply to the sensor here. Alright, so I'm going to back probe this pink wire. Alright, so I back probed the pink wire, which is the power feed to the sensor here. So I'm gonna use this test light to check for power here at the connector. My test light is connected to ground. If I touch this back probe tool, the test light should light. And the key is on in the vehicle. So now let's touch this tool. So right there, as you saw, the test light lit. So we have power going to the O2 sensor here. So that's good. So now we're gonna test the control of the heater. So we're gonna check the ground of the heater. So now we're gonna move our back probing tool to this wire over here. Alright guys, so I back probed the other wire for the sensor here. So this is the control wire, which is coming from the computer. So this ground is controlled. So this wire is gonna have ground, but this is a controlled ground coming from the computer. I have my test light connected to battery positive. If I touch ground, the test light will light. As you can see right there, I'm touching ground, the test light lights. So we have Ivan inside the vehicle was gonna cycle the key for us. So if I touch this back probing tool, as you can see, there's actually ground on it. Is the key on, Ivan? Yeah, so right there. I mean, the test light was on when the key... Was the key off first? Yeah. Oh, okay. So there was ground on this wire with the key off. So now cycle the key one more time. The computer should send ground on this wire. Okay. I guess the engine has to run. Okay, start it. Yeah, so right there, guys. Now the computer is controlling the heater. Okay, so there's ground to heat up the heater inside the O2 sensor. Alright, so turn it off. Alright, so right there. So this checks out the two wires. This test we just did checks out the two wires for the sensor here. So we have power, we have ground coming from the computer, so that's good. So now we're gonna test the other two wires for the O2 sensor, the sensing element itself. So one wire here is gonna be the sensor ground, the other one is gonna be the sensor signal. So let's back probe this one. So I'm gonna back probe this and then I'll bring you guys back up. Alright, so I back probed this wire, which is the sensor signal. So I'm using these jumper wires to connect the sensor signal with my multimeter over here. Okay, so this multimeter is connected to ground, and then the red lead is gonna go over here. So the sensor signal right over here, guys, the sensor signal should have 0.4 millivolts right now. So as you can see, we have 0.400 millivolts. Okay, so my red test lead is going to sensor signal wire. So our signal wire is good. This is the bias voltage coming from the computer. So the signal wire is good to go. So now let's check the other wire, which is the ground wire. So I'm going to switch my back probing tool to the other wire. Alright, so I back probed the sensor ground. My red lead is going to sensor ground, and my black lead on the multimeter is still going to ground, and as you can see, we are reading 0.00 volts. So the ground of the sensor is good. Okay, so this tells me that the wiring is good, the issue is the sensor. And the trouble code that we had in memory was about the sensor here, not the O2 sensor itself. So the sensing part of the O2 sensor is good. The problem is with the heater. Okay, so now what we're gonna do is we're gonna disconnect the O2 sensor and we're gonna replace it. So the wiring is good, we have power, we have ground, we have the bias voltage on the signal wire coming from the computer, we have good ground. So the issue is the O2 sensor. I'm gonna get the O2 sensor replaced, and then I will bring you guys back up so we can erase the trouble codes. Alright guys, so here is the old O2 sensor. So this is the defective one. I'm gonna get it out of the way. So I'm gonna show you the new O2 sensor. So here is the new O2 sensor. It is a Bosch O2 sensor. So I'm gonna get it out of the box. Alright, so here is the new O2 sensor. Let's remove this. So we're gonna install right there, guys. This is the O2 sensor that we're gonna install, okay? So I will get this O2 sensor installed and then I'll bring you guys back up. Alright guys, so I got the new O2 sensor installed. So now let's go inside the vehicle and look at the data. Alright guys, we are back in the vehicle. I turned the key to the on position. So now we're gonna bring up our scan tool here. The scan tool is connected to the vehicle. Let's scan this. So let's go to, since we have replaced the O2 sensor, let's go to service, resets and relearn. Let's see if there's a relearn for the sensor hearers. So we're gonna go through this list. Right over here, guys. Replace/relearn oxygen sensor. So we're gonna click on that. So over here, we have one TSB. And then on the bottom tab, it says functional resets and calibrations. Let's click on this TSB and see what we have. So we have one TSB. Let's click on it. So here are the trouble codes that this TSB applies to. And here are the recommendation and instructions. So I'm going to read this. It says, if normal SI diagnostics does not lead to a resolution and an intake manifold leak or an exhaust leak is suspected, the use of J41413-200 evap system tester smoke machine or the J41416 ultrasonic leak tester, or possibly using soapy water and low pressure air into the tailpipe may be useful to find the leak. So basically what they're saying here is this trouble code can be set either by a defective O2 sensor or an exhaust leak in the exhaust system or a vacuum leak. And they're telling us what we can use to find those leaks. We can use a evap system tester smoke machine, or we can use an evap smoke machine in the intake to see if there's an intake leak, because a leak in the intake or in the exhaust will cause this trouble code. And also here they say we can spray some soapy water. So basically that's one thing to know. I mean, an exhaust leak can cause this. A leak in the intake manifold can cause this. So we don't have none of that. Let's back out of here and let's go to functional resets and calibrations. Alright, so let's talk about why we have to do these resets and calibrations for the O2 sensor hearer. Well, we have to do this because when a O2 sensor ages, the resistance of the heating element changes. Let me give you an example. Let's say the resistance of a heating element of an old O2 sensor is 4 ohms. The resistance of the heating element of the new O2 sensor is going to be less. So let's just say 1 ohm. Well, since the computer is used to this old O2 sensor, this O2 sensor with the higher resistance, I mean in this case the old O2 sensor, is going to require more current to keep this heating element hot. But the new one, which has less resistance, which is 1 in this example, it's going to require less current to keep it hot. So the computer, not knowing that the O2 sensor has been replaced, the computer is still going to think that the O2 sensor that's on the vehicle its heating element has 4 ohms of resistance. What it's going to do is going to send a lot of current to keep this heating element hot. But since this is a new O2 sensor, the new one has a lower resistance. If you send a lot of current to it, what's going to happen? It's going to burn. It's not going to last, right? So you can replace your O2 sensor. A couple weeks down the road, the same code comes back and you think you had the bad part, but the issue was the computer not knowing that the O2 sensor has been replaced. So basically you have to tell the computer that the O2 sensor has been replaced and this new O2 sensor has potentially lower resistance. Okay, so let's go to It's in Calibrations. Click on that. So we're gonna click on O2 sensor here, learn reset. Let's click continue. And right there it says reset completed successfully. So let's exit. That's good. So let's back out again. So now let's go to the engine computer. Let's look at the data. Actually, let's erase the trouble codes first. So let's clear the codes. We replaced the O2 sensor. So let's go back and see if the codes are cleared. So right there are no fault codes present. That's good. Let's go to data display. Let's go to sensor data. So let's graph these two guys. This is where I wanted to see. They definitely mirror each other. Now let's look at the amperage reading. So right over here, this is the first O2 sensors on each bank. So bank 1 sensor 1, bank 2 sensor 1. These are the O2 sensors before the catalytic converter, and these are the O2 sensors after the catalytic converter. And as you can see, the amperage reading is definitely close to each other. Okay, the amperage reading on bank 1 is close to the one on the sensor on bank 2. Okay, so this is good, guys. This is fixed. Alright guys, this is good. This is fixed. I'm happy with this, with the numbers I get. As you can see, the hero amperage on the first O2 sensors, they're both drawing pretty much the same amount of current. Also over here, same thing on the sensors after the catalytic converter, and as you can see, they're both drawing 1.04. So they're fluctuating between 1.02 and 1.04. So this is good, guys. The problem was a bad O2 sensor here. Okay, let's back out of here. Let's see if our codes are still off. So right there, we don't have any trouble codes. So I'm gonna turn off the engine so we can wrap up this video. I don't even have to test drive this. I'm sure this is fixed. So let me turn off the engine. Alright, so that's it, guys. I'm going to leave it right over here. This is how you test and replace an O2 sensor. So the problem with this vehicle was a defective O2 sensor. The heater in the O2 sensor was defective. And on these GM vehicles, when you replace the O2 sensor, you have to relearn the O2 sensor heater, okay? You have to reset it. Otherwise, if you just throw a sensor on it, the computer will still think that the O2 sensor is still old, because the resistance of an old O2 sensor heater is going to be different to the one of the new one. So you have to do the relearn, otherwise your O2 sensor is not going to last, because the computer will keep sending the same amount of current to keep the heating element hot. And if it's an old sensor, the resistance is going to be different. So you have to do the relearn. It's important, guys, otherwise you'll keep changing sensors on the vehicle. All right, so I'm gonna leave it right over there. I hope you like this video. If you do like the video, give it a thumbs up. If you don't, give it a thumb down. But if you do, you gotta tell me why, so we can make better videos in the future. If this is your first time here, subscribe to the channel, ring the bell so you can get notified every time I upload a new video. If you have any comments, questions, criticism, leave them in the comment box. Thanks for watching, guys. See you next time.